A very good evening to everyone. On behalf of India Space Lab, I warmly welcome all the participants to today's session. It is my privilege to introduce our speaker for today, Mr. Gaurav Sir, who is highly skilled in AI and ML applications and aerospace technology. He has participated and won in several prestigious space competitions, including the In Space Model Rocketry Competition, where he designed an advanced GCS ground control system integrated with AI ML based applications. He possesses strong expertise in ground control software development, intelligent system integration, and aerospace technology applications. And we look forward to gaining valuable insights from today's session. With this, I respectfully invite Mr. Gaurav to take the session forward.
Hello everyone, am I audible?
Yes, sir, you're audible.
Students, you can, uh, I'm audible to you, and you must be, kind of excited, kind of, bored, waiting for me, or okay, good evening. So, yeah, how many of you how is taking their primarily goal for learning this ground control station in a way that you are going to build one? So rather जब हमारे पास होता है like for the first time when I was started building the ground control station for the first time, I had a goal in mind that I have to make one in a deadline. So there were not really much tutorials for this specific topic on the YouTube. Tried finding one, but yeah, so here it is. So after, you can say, 2 years, almost 2 years, I can assure you that साउंड नहीं आ रही है एक बार confirm everybody if I'm audible or not.
So
Okay.
you're perfectly audible. If any student has any problem with
Rahul,
that
maybe you
audio
need
thing,
to
kindly
check if
rejoin.
everything is clear from your side. Yeah. Okay, okay. So most of you students, can I know how many of you are familiar with the uh, basic? अच्छा ठीक है, ठीक है, ठीक है। ओके, सो अभी ये कोई बता सकता है कि कितने लोग फेमिलियर हैं पहले से विद द HTML CSS JavaScript, the standard web dev, and on top of that the MERN stack. We don't specifically need the MERN stack here. Okay, little bit. Yeah, yeah. So let me introduce you to what it is and how it works. In this session of 2 hours, we'll see the fundamentals of what is a ground control station, how it works, and how you can build your own. Okay, don't spam. I can hear you. I can, Rahul. I will switch language as per your preference, but yeah, don't spam in the class. Let everybody. Okay, Hindi, Hindi. It's fine. It's fine. So yeah. Okay, so let me share. I hope everybody can see the screen that I'm sharing. This is what a ground control station. Okay, no, we are not going to start with the example. Let me tell you the basics first, and then we'll see. So ground control station is this is basically a software for a hardware hub. Uh, करता क्या है? It monitors the command and command unmanned systems, displays real-time telemetry, log, transmissions. This is all written, so I think you won't have much problem understanding. But in actual, let's see what is a ground control station. जब हम कहते हैं कि हमें एक जीसीएस चाहिए हमारे अनमैन्ड सिस्टम के लिए, वी आर ट्राइंग टू बिल्ड यूएवी, or we are trying to build a drone, or maybe a CANSAT model satellite, or maybe a model rocket, or maybe some kind of thing that will go up in the sky, or some kind of thing that maybe go up far away from the device that you are building on. अब मान लो, जस्ट सपोज फॉर दिस एग्जांपल, लेट्स से कि हमारे पास में एक कार है छोटी सी, वी आर ट्राइंग टू बिल्ड अ कार, जैसे हमारे पास डीसी कार्स होती थी छोटी छोटी, 500 वाली आती है, बट उसमें कोई सेंसर्स नहीं लगे रहते हैं अपार्ट फ्रॉम द वन जो कंट्रोल करता है उसको। ठीक है, लेट्स से वी गो मोर प्राइसली, अब हमारे पास सेंसर्स हैं और वो सिस्टम थोड़ा ज्यादा कॉम्प्लेक्स है, सो वी हैव द होल थिंग दैट कॉस्ट, द लिटिल कार दैट कॉस्ट अराउंड 50,000, सो इट मस्ट बी हैविंग मच वैराइटीज ऑफ सेंसर्स। ठीक है, तो अब क्योंकि हमारे पास इतनी सारी चीजें हैं, वी वुड लाइक टू सी कि हाँ वो काम कैसे कर रही हैं। ओके, सो जब हम कहते हैं कि मेरे पास कोई कार है या छोटी सी कार है, रिमोट कंट्रोल कार है या ड्रोन है, अब उसमें हम सेंसर्स अटैच करते हैं, वी इंटीग्रेट सेंसर्स ऑफ देम। सो व्हेन द सिस्टम, व्हेन एनीथिंग अ पार्ट ऑफ हार्डवेयर दैट वी क्रिएटेड, इट इज फार अवे फ्रॉम वेयर वी आर ऑपरेटिंग। अब ड्रोन तो हवा में है, सो यू कैन नॉट सी दैट व्हाट इज गोइंग इनसाइड दैट ड्रोन, इवन फॉर अ रॉकेट, इवन फॉर अ कैन सैट, इन एनीथिंग यू वॉन्ट अंडरस्टैंड दैट हाँ वो तुम्हारे सिस्टम से दूर जा रहा है, बट उसके अंदर चल क्या रहा है। So the ground control station is basically a software, or in terms of rocket or anything, when we take up it as a big number, जब हमारे पास कुछ ज्यादा प्राइसली होता है तो it's a kind of fancy statement, we say it's station. So the GCS or software is basically a hub where you can control your hardware, where you can integrate, or where you can communicate with your hardware. अब तुम्हें अपने ड्रोन को बोलना है कि ठीक है वापस नीचे आ जाओ, सो यू मस्ट हैव अ कंट्रोलर जो बोले। ठीक है, बट व्हाट इफ तुम्हारे पास कंट्रोलर नहीं है, व्हाट इन रियल टाइम, सिस्टम सारा वहीं पे है, तुम्हारा कंट्रोलर तुम्हें रीडिंग्स नहीं दिखाता है, आजकल तो एडवांस कंट्रोलर्स हैं तो वो सब भी दिखाते हैं, बट यूजुअली नहीं दिखाते हैं। तो ग्राउंड कंट्रोल स्टेशन में द सॉफ्टवेयर इज समथिंग जो तुम्हें कंप्लीट टेलीमेट्री लाइफ टाइम, ठीक है, जो वहां से रिसीव हो रही है, और तुम्हें सामने अगर कुछ भेजना है तो वो तुम्हें दिखाता है। ओके, explain in English. Okay, okay, okay. Yeah. So the ground control station is basically a software hub when you have a hardware which is far away, which is XYZ distance away from your software or from your laptop, and you need to see that what is going on inside that hardware. So you built an interface for that in your laptop. Using that, you can address the real time telemetry or the transmission coming from any kind of thing that is a hardware. How now, let's understand how we do that and get more into ground control station. More importantly, if everything goes right until the end of this lecture, uh, I have built several ground control stations. They are on GitHub. They are completely for the tutorial purpose. So if you want to build one, you can just copy the repo and do that. But we'll see how we are going to build one. I'm not saying we are going to build a ground control station interface. Rather, we'll be just cloning my repo and see what I've built. I'll explain you. Hindi not good for South students. I'm from Gujarat, but we should understand. Okay, just cope up with. I will try to use, the robot kind of phrases that you will understand, like monkey eating banana. You understand? This kind of Hindi. I think that settles it for everybody. So yeah, don't comment over language. It is fine. Okay, so how does it work? The GCS connects via radio, cellular, satellite link to the payload. It decodes incoming telemetry packets, interprets. Okay, that language is too complex. Oh my God. What I'm trying to say here is the ground control station that receives the data. You see this guy, on his laptop, and you see something that is going on from there and something that is receiving in. And this is a kind of a hardware that you can say, a bunch of that looks like a highly complex hardware. Okay, so when we talk about these things, you want to know that, okay, this thing looks costly. It must be, around 40-30,000. And you want to see that if it goes on the air, what will come out? What is happening while it's in the air? So you won't be able to see the readings until and unless you connect it to some kind of an antenna. Okay, so so you connect two antennas, one on the ground control station, one on this device, and you make this antenna forward the data to this interface, to the ground control station. So what happened next? So basically, you have built an interface. Uh, you already know that what kind of packets, what kind of telemetry data. When I say packets, I mean data. When I say any kind of term like telemetry packets, interpretation, sensor readings, it everything means one thing, that is data. So any kind of data that is coming from this antenna to this ground control station. So the ground control station also does have a receiver antenna. Okay, so it helps uh, the GCS software to understand what kind of data is coming from, and the GCS decodes that kind of data and shows it to you in numeric. Okay. Sorry. So here you see, this is how an interface, a typical ground control station interface look like. I don't see, this is a very kind of futuristic, but in reality, it doesn't really look much complex like this. Rather, it's more easy to understand when once you try to build it. So the effective UI, we have a UI. Up now, you see the data is anything that goes above, anything that goes far away from your device, when it is sending you data packets, not in just one form. It will send you data packets, let's say for multiple readings, and you want to interpret those readings into maybe graph. अब इसको भी एग्जांपल से समझ लेते हैं. लेट्स से आई हैव अ कार, एक्सपेंसिव कार इट इज, एंड इट हैज एन मॉड्यूलर एंटीना अटैच्ड ऑन इट. अब वो कार जा रही है स्ट्रेट अप, ठीक है. आफ्टर अ फ्यू मिनट्स आई वंडर ऑफ this is a foggy environment or a cloudy environment, so I don't know, it went off somewhere, and I'm trying to find, okay, where it went off. And even if it did, how it is, how it's responding to the environment, what it is doing. Are my sensors safe? Are they sending me data? So these kind of things. And again, they will give you some kind of signal. Even if you receive some kind of signal in your interface, you'll feel like, okay, these are just numbers. How do I know which reading is altitude, which reading is showing me the pressure, which reading is showing me what value? You'll just see numbers 28, 33, 44, 62, maybe decimal numbers, any kind of that. So you feel like, okay, I don't know how to interpret these numbers. I don't know what they mean. So now you go ahead and build an interface. So you build an interface that receives the data via a USB, and the USB receives the data through the antenna. Okay, so your interface receives the data inputs, and it shows you that, okay, this kind of data is that. Okay, in a more descriptive way, using modular widgets like the graphs, you say the log systems, these kind of things. Okay, so if anybody is having any kind of doubt, just feel free to ask me. Since I know this thing can be literally easy to build at times, but for few of the people, like when I started to, when I was in requirement of building a ground control station, it was really a complex task for me, since there are not very much lectures about the ground control station. There aren't very tutorials about how to build one like that. So rather time when you have to build anything, requiring a GCS, you'll be scratching your heads if you don't have any kind of prior information. Okay, won't it have latency? Yeah, latency is a factor. So we try to choose the tech stack, since the HTML, JS, CSS. This is the modular tech stack. This is really easy to interpret for computer. let's say even if we write, if I want to know that if you guys are familiar with C++ or DSA. Yeah, yeah, yeah. Yeah, I will explain more about how do we counter the latency. How do we just don't raise your hand, just ask anything you want to. Okay, so how do we counter latency? Latency, yeah, I think I need something to explain you guys. Let me go grab a whiteboard so stand better. Okay, I'm back now. Yeah, basic CV notes. Okay, it's fine. Everything's fine. The goal is to understand what's going on rather than focusing on what specifically that you can change. Okay. How do I share a whiteboard? Let me just stop sharing the screen. Focus, everybody focus on the whiteboard. Um, I would request the host to stop annotation for everybody so uh, everybody is not, start drawing on the screen. Okay, I would request the host to, stop annotation for. Okay, yeah, it's fine. Sorry, man. Okay, so let's first understand how the basic thing works. Okay, I think it's very like latency is the time difference between the input provided and the output generated. Yeah, quietly. Great. That's quite true, but okay, I hope you guys can see the screen. Uh, you can see the whiteboard. Now let's say how it works. This is expensive hardware you have built. Okay, this has multiple sensors. See, these are multiple sensors integrated into this piece of hardware. Okay, I don't know why it's not working. This is your hardware. Let me draw this again. Yeah, this is the expensive piece of hardware you have built. Uh, this is the antenna, let's say, and these are multiple sensors, costly ones. Okay, so you have integrated inside your can set, and this is, let's say, 1,000 feet above the ground. This is your laptop. Okay, so when you see that there is a great distance, okay, let's say X distance. x meters. Okay, so now you're trying to say that this is a receiving end, by the way. So this is your antenna. There are lots of, environment factors and clouds, and so you cannot really see what your CANSAT or what this piece of hardware is feeling. When I say feeling, I mean what is it going through the sensor readings. Okay, so this is the basic flow. You have attached an antenna, you receive the data from the antenna, and this is your laptop that is receiving the data, and it is receiving in the form of 0A, 3B, 1C. This is the hexadecimal format, or maybe you can say in the form of binary. And this is just an example. So this is a hexadecimal format. Now you don't really know that you are not going to interpret this lifetime of zero means this, A means one, and this is kind of a reading for something else. So you build an interface that will take the data as an input, okay, as quickly as it can, and it interprets into numerical values with not just numerical values. It converts your inputs into anything you want, like graph. Maybe I want to see a live cam computer, the camera that, let's say if I've integrated any kind of camera inside it, so I want to see what's going on through the camera, or maybe the graph, and any kind of numerical values, or maybe if I want to, I can integrate a map. So when you receive the data through the ScanSat, through the sensors, it is going to transmit you through the antenna. And this is the kind of values you will be getting out of the antenna. Okay. This is the values you are getting. And this is a dashboard, or maybe this is the ground control station. Here you will see that, you know, the graphs and all kind of sensor values going on, these things. You're going to see that, okay, this is altitude is 23 or 100 feet, in this case 1000 feet. Okay, so these kind of so the hexadecimal format is being converted into this input, and you get to see this. And that is what we called as a ground control station. ये पूरा workflow है. And let's understand furthermore on how we built one. Okay, what are the things involved? So about the latency that uh, anyone was commenting. Okay, so let's say your hardware is capable enough, the antenna is capable enough to send you at 1 hertz. That means every second you're going to receive, let's say, almost x, yeah, y number of, or maybe n number of packets. Okay, so your antenna or is going to send you n number of packets. Now the main goal is to realize that how will you show the n number of packets, how much will you receive, and as fast as you can receive, how fast you can show in from the input to these what we call the UI, how you can represent the data in your UI, the interface. So it's about latency. So the hardware is capable enough to send you the data at per second, data packets and number of packets per second, both the antenna at the receiving side and at the transmission side. They can send you the data at, n number of packets per second. Now it's your task to as quick as you can, just interpret this data into the front end, save it lifetime. And when I say this, there is a lot of stuff going on when we build a ground control station. It looks easier on one end, but when you go to build one, it's not really that easy. When I say this is the data you are receiving, so let's understand the complexity on what happens. Let's say this is port 1, this is port 2. These are both USB ports attached in your laptop. Okay, so you are receiving the data on these both USB ports. Let's say one is the cam port, this is the camera, and this is receiving the pixels value. Pixels means whatever there are sensors, okay, and this is a camera. So camera, you can see what the camera sees here. This is what you are receiving, and through this pixel you are receiving the telemetry, or means the data. Now, what the game is, let's say when I say data, I mean, let's say you are receiving 32, wait a second. Okay, so when I see data, I mean, let's say you are receiving 32 packets and you have to interpret that lifetime to see in, lifetime. So you have to calculate the latency on how to compromise on the latency. We'll talk about that. Okay. So, as somebody in the chat says, it is basically the time that is consumed between the input and the output, the calculation of the input and the output. So, in that way, that is known as latency. The how fast you are receiving the data and how fast you can interpret it. So, the user sitting in front of the laptop can see the screen. Yeah, yeah. So the point of latency is there are two things that does matter. First, at the hardware end. Second, at the software end. Okay. So when I say the hardware end, the latency matters of few scenarios. Uh, you can say bad weather. ठीक है. तो तुम्हारा antenna, the antenna was not really functioning. That might be one case, or maybe any kind of sensor. ठीक है. Sensor stop responding, or the data is corrupted. Anything could happen. ठीक है. So these are the things, anything, etc. Similar problems can happen at the hardware end, but in the software hands, we are really likely to, really less likely to curate any kind of problems. See, it is really easy for the software, which is, let's say, the backend is deployed on the Python, which is interface of C++. So anybody know familiar with C++ or Python would be easy to interpret this what I'm about to say, or yeah, it is going to be easy for you to understand it anyways. So any kind of are there limitations of gas in the hardware view? Yeah, also it can happen, maybe due to smoke or some kind of reason. But as far as I have my knowledge, I don't think that's very likely the case that things like gas or smoke interprets the data, since antenna can pass through that. So this is the software end. At the software end, you will just it is really easy for the software end to replicate or to convert the data, since all the part of software is to just convert the data and represent it. So these are the two things, okay, so that happens. What happens is really, you see in the back end you'll receive, let me just delete it one more time. In the back end, there are two things in the software. In one terms, we are going to talk about that, since when building something like that involves several process, maybe 17 kind of layers, but we are going to talk on the simplest layer that everybody can understand: front end. Okay, so there is the back end and the front end. What happens is, in the back end, when it receives the data in the form of 0A, 1B, and this is taking example of hexadecimal number, and it has already set of values assigned it. So I need to receive the altitude, I need to receive the speed, or you can say the velocity, I need to receive the pressure, you know so these kind of data that is being transferred to the backend via the Zigbee or via the USB. Okay, so the via USB, the backend receives these kind of data, and it interprets in the form of, okay, this is 0 is going to be altitude, A is going to be speed, 1B is going to be pressure, and it interprets that data and it sends those data packets to the front end and your front end being already assigned with the altitude values, and यहाँ पे बस there is something NA. There is altitude written in NA, and there is a graph of pressure. Why this is lagging so much? Okay, so there is a graph of pressure. So as soon as the backend receives and interprets the value, okay, this is going to be 1 and the pressure is going to be 1B, it sends the data packets to the front end, and as soon as the front end receives the value of the pressure, it is going to update this graph from 0 to something, some kind of value. Okay, so this is how the pressure will work. This is an example. Okay, let's say the backend receives the data telemetry packets of 0A as the latitude and the longitude. This is the backend receiving latitude and longitude, and it sends the front end. Okay, I'm receiving the latitude or longitude, or maybe the location in terms of the hexadecimal, and it will send the numeric value, and the front end will say, okay, you receive these values. I'm going to plot these values on the map. So this is a map, and you will see that, okay, this thing just updated at location. So now you understand why we require a ground control station. Being imagine just seeing the data packets not in the form of data packets, but in the form of UI that is constantly updating itself, so that you can see that where your hardware is in lifetime, what is doing, what it is feeling, the sensor readings, all of that stuff. You can calculate everything in the lifetime. Line. And when I say the problem of the latency that you receive at the software, or maybe the software end, or maybe the back end and the front end, that is very less likely to happen. Mainly it is because of the libraries issue. Okay, libraries issue हो गए, या maybe it is because upon the dependencies, like you installed, since let's say I'm using chart.js, a JavaScript library to represent the chart, to represent these, to make these kind of charts. So when I receive the XYZ value in the back end and it sends the front end, maybe the chart JS version I was using the 14, and with the back end it was compatible for the 15th one. So this creates an issue. So these kind of things might create an issue. Otherwise, that keep the tech stack so simple that the only problem you'll be having is at the hardware end. And from my experience, for the I have built across 5 ground control stations, and all of them were for the team that ranked almost second, anything almost more than second AIR. Okay, whether it's national or international competition, I'm going to show you later. So I've built GCS for this team, and according to my experience, every kind of problem, mainly 20%, only 20% in rare cases. Rare cases, in 20, just 20% of the problem was at the software end, and that is too rarely. In the common one, it is like about maybe 2 to 3%. That's it. 2 to 3% problems I was facing for latency at the software end. But in most of the cases, it was mainly majority percent, the hardware. So in our case, we don't need to be worried about, how we are going to build the software. It's really important to choose and stick with one tech stack, and yeah, that will solve much of the problems. Just so how do I stop sharing this whiteboard? So okay, were you guys able to see the whiteboard? Okay. I thought maybe for all this time I was just showing it to myself. And okay, it's fine. How do I stop this? Yeah, let me stop sharing this whiteboard. Ah, and let's start with the presentation again. If you could please share your LinkedIn profile. I need your guidance making ground. Okay, okay, okay. Yeah, very great. Finally, a project at a ground control station. That's really great. Uh, Building something like that in your final year is amazing. This is a super cool project since most of the time when you see students coming up with a project like a front end developer or a back end developer, it is just the software thing. It is not limited to the hardware, but that is not what happens in the real time. In the real time, you'll be facing with latency at the both end and the software and the hardware, and you'll be always confused with how to manage that. But if you're building something like that that interprets the data from the hardware and shows it as a good UI in the front end, that is called engineering. What all hardware used? Hard When I mean by hardware, it's let's say a bunch of sensors integrated into a PCB, and the PCB also has an antenna, so your antenna sends and communicates. Okay. How does this work? So I've already explained it. This is the standard. If you guys can see the screen, why can't we directly add a controller? Yeah, you can directly add a controller, but most of the cases uh, you won't be working with just a UAV. When I say UAV, I think most of you guys are interpreting with the drone, and that is not entirely the case. When I say UAV, and when you say UAV, a lot of the times when you say, okay, I'm going to build a drone, and I want to know how it performs. You have seen the VR kind of what do we call that? VR kind of thing in a drone. I don't know what do we call that. It is really cool stuff. A solid fuel rocket motor powered. Okay. Yeah. So we do since the first thing, I built ground control station because it is kind of a requirement, and I was in the software part. So yeah, first person view FPV. So likewise, when we see an FPV drone, we don't really know how the drone will be performing, how the drone will be moving, side to side or any kind of direction until and unless we see how it is moving. So we see in a lifetime, and that is through the antenna. What technology? I will explain. But yeah, let's talk about the UAV. Why can we directly put a controller? Because you need to know that what kind of values you are receiving for the future purpose. I need to know how were my sensors performing. Were my sensors able to calculate the altitude in the lifetime? Were my sensors able to take decisions that where the drone wants to go or where the rocket wants to go? There was recently a problem statement where they were asking that after the deployment of the CANSAT from the rocket in the midway, you need to calculate that where it is heading towards, and you have to guide through a particular location. So until and unless I do not know at the ground control station where my rocket is headed, how would I be able to know that how I'm going to control it? Okay, so things matter, which is good for drone or MCU, SBC, and which model of them. I don't know if you're talking about the software part here, since my expertise lies in that, although we can clear it out after the session. Okay, so I hope you guys understand why we need a ground control station. You need to know that where your hardware is going, how your hardware is performing. If your hardware has a problem at at the end where you cannot really see what is going on. Let's say if some kind of sensor really started burning in the air, how would I be able to know that? Okay, the sensors are burning. I should integrate. I should send a command from the GCS to release the sensor out of the rocket. There are stuff like that. So how would I be able to know? So the standard example is ISRO or any kind of space station or space agencies. They use a really big and ground control station, and the station is divided into several parts that monitors the health, the monitors the patterns, and stuff like different formats of data on how the rocket is really performing in that end, since you cannot really climb up the rocket and see where it is going. You need some kind of a way to see what it is doing. Well, okay. Yeah, Himanshi, you can ask the question. You can ask anything you want. We're just halfway through the session yet, so we have another PPT to finish. So yeah, any questions you have? So could you please explain the whiteboard part one more? Give it a short recap. Okay, I will surely do that. So your build code has any sensor gone bad, started giving wrong value? How we are able to identify? Yeah, when yeah, and the real experience that I had with my ground control station is that I had a misinterpreted value. For example, the data packets were that I was receiving were XYZ, and let's say due to some kind of problem I had mixed data packets or some missing ones, so I only received X and Z. I did not receive the Y value. So my ground control station, since it was the first time and it was being badly handled, so I was able to I was not able to interpret. So I thought maybe the Y value is not coming, but that was not really the case. It was the issue at the hardware end. But so things like that matters. And let's say you are going to train a machine learning algorithm that will interpret that how far how the conditions are going to be at a certain level. Let's say my rocket that flew that was in the air for about 500 feet, and I have received every single packet from those values, the altitude, pressure, temperature. Maybe I can put all of that data into a machine learning model and calculate that, okay, how the pressure is going to be after at this feet or that feet, you know. So things like that. So when I have the data, I can interpret into anything. So that is data science. I have Raspberry Pi 4, 5, Arduino Uno. Okay. Which controller is better for satellite technology? So the Raspberry Pi 4 is not really a microcontroller. Raspberry Pi series, the Pico Uno and Nano ESP32, these are the controllers. Raspberry Pi 4 is basically, a device, you can say mini computer, that is used for much more complex tasks than just interpreting the data. Microcontrollers, anything is fine. I think I used maybe Raspberry Pi Pico at my time, which is good for a drone. Okay, sir, if we lose the Z coordinate, can we use the Cartesian 2D method for holding the altitude or reaching the home area safely? I did not understand what are you asking. Uh, how is the backend architecture designed to handle continuous data streaming from multiple drones in a GCS? Yeah, that is a clear question. That is what I was asking. That is what I was looking for. Let's see how it handles the backend. Okay, so first let's understand this is the process flow of what happens: the sensor data collection on the payload, the wireless transmission. We receive or transmit the data. The data reception on the GCS, we receive the data at the backend end. Then the Python and at the backend is coordinating or basically communicating with the electron through this protocol, the WebSocket or IPC. And then we can see the data flowing, the data visualization in real time in the interface. This is the example of the ground control station that I proposed earlier. You see, these are the graphs that are going up and down, the descent rate or the temperature, altitude. These are the multiple graphs going up and down at the same time. And now, since somebody was asking that how to handle continuous data streaming, you see that I'm going to receive when I'm going to receive the data from multiple ends. These are as you can see in the PDF in the temperature section, there are data IoT station 1 temperature and the 2. So that means basically I'm going to receive the data. I was receiving the data from two ends, so there was not a single port, there was dual ports. And when you have multiple ports, it is slightly difficult. It gets slightly difficult to communicate, to interpret the data, and you have to build some kind of system that can understand what sensor value is coming from what port and where you have to represent it. So yeah, but how it looks in the front end part, this is basically how I used to differentiate it. This is just an example. Okay, don't worry, I'm going to Viraj, I'm going to cover it in the in later in the lecture. Possible for a single data error to lead to a subsequent. Yeah, it is. A single data error can really crack up the whole packet you are receiving at a second. You have to handle that. There are ways to handle that, which I was not able to do at my time, but surely I can teach you now. Okay, so this cat will come in the end of the lecture. Let's just continue to another PPT. So to see much more things in details, I hope most of you guys are able to understand what I'm trying to say here. Since again, GCS building a ground control station is easy at sometimes, but you never really know what thing can cause problems. So since it's software stuff, so you cannot really mess up at the software end. Okay. Oh, see, it's an example. It's if I can share my screen, I would love to. Let me show you an example of the ground control, the UI of a ground control station that I built earlier. Desktop capture. You see? Okay, can you guys see this one? Okay. Yeah. So this was the ground control station, the example of a GCS that I built. This was all according to the needs of a particular competition of the Technofest model satellite. So there are lots of values and lots of things going on, and at first glance it can look a little complex, but as you start building, as you follow the standard process of the software engineering, you won't have much complications. In the simple terms, what we can understand here, these are the graphs. These are the sensor values, the pressure, altitude of the CANSAT and the rocket, and the descent rate. Descent rate is being calculated with the sum of these values. And there we have a orientation dial. So basically, on the basis of the values receiving from the pitch, roll, and yaw, I was able to calculate how the satellite is keeping its orientation, whether it's going 30%, 30 degree in the X or 40 degree in the Y. So it was able to change its rotation. So though this was a PNG image, I later converted into a 3D one. I will show you later. These are the temperature values of the from the both stations. These are the GNSS or the GPS value. See, this is the live video stream of the cam. Okay, what is your rocket seeing at the live end, and this is the status. If the camera is working or not. And this was the problem statement. We have to change some kind of command, so it will change the color. That was it. And this is the IAS console. This is something that is really good to integrate into your system. It shows you what kind of things are working. Let's say your descent rate is completely fine, so you say in range. So there are you have to set the formulas in your backend. Like if the pressure is great, the altitude is good, you can say on the basis of the pressure and altitude, you can comment on the descent rate of the CANSAT. On the basis of pressure, you can comment on the pressure, of course. Okay, now who started this? Please don't. I have to stop. Can you disable annotation for others? Yeah. Okay, it's fine. Could you please explain the whiteboard part one? I will, which is good for drone. And can somebody please reply to Madhav about which is good for a drone? Catch up the complex things you're telling. Okay. I'm extremely, I apologize for that. If you cannot understand, let me just explain everything from scratch
Excuse
one
me,
more
sir.
time, uh, so you guys can all understand what I'm trying to say. Okay. So don't
Excuse
worry,
me,
it
sir.
won't, for those who understood everything, it won't take much time.
Sir, am I audible to you?
Until then, would you let me know that how many of you earlier started, building a ground control station, or you are in requirement for that? I want to know that how many of you are interested in building one. So it will be more easy or maybe more interesting for you to attend this lecture rather than just hoping for a certification. Okay, okay, okay. I get it. Great. Computer science students. Yeah. So it is really an interesting work when you see the ground control station is uh, what if okay.
I request all the
Yeah.
participants not to draw
So
anything on the whiteboard, please.
interested in building with AI integration. Yeah, okay, that seems great, and that will be helpful to you in a case because I have done it earlier, so I can explain to you. I would request all of you participants to please value the money you have paid for and not just do anything in the annotation section. So you can just take as much as knowledge you can, since you know knowledge is the key factor here. I would like you please share your number. Okay, I will share you my LinkedIn. I'm interested. It's becoming a monster for me. Okay, okay. I will comment down my uh, LinkedIn in the section. Okay. So please do not do anything in the whiteboard. Let me just teach you. Okay. I would request the host to set up the conditions so I can just explain why through whiteboard since.
Excuse me, sir. What are you saying to enable?
Okay. Let's understand it one more time. Okay. In simple terms. Everybody look in the screen, look in the whiteboard, comment down anything if you did not understand from scratch. I'm going to explain it as many times as you can. And even after the lecture, if you want, you can reach out to me. I'm always available on the LinkedIn.
I request the participants
Okay.
not to write anything on the whiteboard.
So let's see what happens. Let's understand the whole process on what happens when we build and why we need a ground control station. So this is your laptop. I hope everybody would have understood the basics right now. Let's say this is your very big of a rocket which has a uh, good no this is a nose cone, and this is the ignition. Okay, I'm actually good at drawing. I did not know that. See, this is the rocket. Okay, so no, please don't. Okay. I would request you people to stop messing with the
Excuse me,
whiteboard.
sir. So nothing is visible
Screen
on the
is,
screen.
I can see drawing. How many of you can see what I'm trying to do here? Really? I thought I was presenting the whiteboard. No, stop the sharing. Hmm. Look. Hmm. यहाँ पे प्रॉब्लम ये है कि मतलब बच्चे वो व्हाइट बोर्ड पे कुछ ना कुछ लिखे जा रहे हैं, तो ये भी एक दिक्कत आ रही है। उबंटू में नहीं होता यार कोई। हाँ ये दिक्कत आ रही है।
I request all the
Okay,
participants,
so
please do not write anything on the board since it is creating an hindrance in the class.
I guess most of you people are trying to ask, genuine questions. So please do not turn off the chat. Okay, let me clear the page. I'm trying to share this. What do you know? What is the name of this? I'll tell you everything how to avoid such errors, like the one with not receiving the data. Can everybody tell me that the whiteboard is visible? Still, yes, yes. Okay, okay, that's great. That's great. Okay. Okay, everybody focus on here. Again, it is going to be sounding quite boring for some people, but don't worry. For those, it may sound boring. Fundamentals are great to know, even from for me. Okay, so this was your rocket. Okay, this whiteboard thing. I'm so confused. But should I share or not?
So again, your whiteboard is disabled.
Wait up, I have a solution. Um, um, Host, can you please just turn off this whiteboard for everybody?
So there's no such option to turn off for all.
Yeah, MS Paint is really great, but you see, I'm on Ubuntu operating system, so we don't really have that option here. Don't worry, I'm going to use a browser version. Yeah, it is visible, but we do not need that. So let me share my screen instead. Until then, any kind of questions, just keep throwing questions on whatever, even the complex logics that you cannot understand, even from the simplest doubt. As far as my knowledge is helpful for you, it is okay with me. So I'll be, you can also maybe in the iOS. Maybe you can use an inbuilt whiteboard for the browser. Yeah, I'm trying that. Yeah, I guess. Okay, now I guess I can share my whiteboard. Collaborating on a whiteboard. What is it? Is this? No, okay. So in a GCS-based satellite communication system where the connectivity is intermittent like LEO satellites, how can a DTN improve data reliability compared to the traditional real-time communication protocols? I don't specifically know what DTN means into a reference, but I can tell you that the common protocols that we use here and why they are reliable. Maybe DTN is something industry standard type, so people use in the the standard communication system, like when building something like a drone. Uh, is there any communication path which works in any weather? Um, as far as I know, maybe any kind of sensor, any kind of antenna at a good frequency range is better. GCS is the screen where we can visible. Yeah, you understood that, right, Dr. Arundhati, if I'm pronouncing right. Sir, is there any substitute in making antennas which are resistant to external phenomena like the delay tolerant, tolerant network? Yeah, now I know delay tolerant network. It was used in the industry standard. One of the protocols that is used in maybe the real rockets. But as we are engineers, as we are students, we really don't need to put ourselves in a position to learning more complex things for no reason at all. So let's just understand the fundamentals first. And yeah, I hope you guys can see the screen. Okay. Yeah. So let me just build. Let's really see my. Okay, this is confusing. This is your laptop. Again, this is the dashboard that I was talking about. Here are graphs and stuff and alag, multiple telemetry values. And you have an option to communicate at both ends. Okay, so let's say what was I was, what I was talking about. Yeah, it will be helpful for, will be helpful for you guys if we can understand. Okay, so this is, let's see, this is your rocket. Okay, this is being complicated. Until then, let me just share another PPT so you guys do not waste your precious time. I thought maybe I would explain this when things really get, interesting in the session, but every time some kind of problem comes up. So don't worry about that. I will, any time that you have spent on this video or wasted on this lecture, you will be uh, able to, cover all of that. Okay, I think I'm back with this. Yeah, let me share you the screen. Am I even in the Zoom meeting? Here, okay, finally we are back. This was the now why again started lagging. Okay, so I think we cannot continue the whiteboard. Well, yeah, our only option for is to now just understand the fundamentals through the PPT, and maybe I can show you my ground control station. So most of you guys were trying to build a presentation, or sorry, most of you guys were trying to build a project on that, or maybe your own ground control station. You'd be, you know, you'll get some kind of help maybe from mine. Hope you can see this screen. Okay, so this was the ground control station software. I hope everybody understand the basic knowledge that I was trying to say. That ground control station is a software interface where you receive the data from the hardware end, and you interpret that kind of data into the features, into the UI in multiple ways, like as a graph, as a text, as any kind of thing, UI thing. So where so it makes easy for the user to communicate with the hardware in the real time, maybe sending any kind of signal from the GCS to the hardware, or maybe receiving any kind of thing from the hardware to the software. Okay, so that is the solely of purpose of the ground control station, and the biggest example we have seen is, you all must have seen the Mission Mangal movie. You see how much bigger of the station they have at ISRO. Okay, so yeah, hey, you see, uh, this is the operational nerve center. Here is the dashboard. Are you able to see the dashboard? Are you able to see the screen? So this is the dashboard that we see, you know, and here is the rocket. Here is your rocket. You see, there is the electronics, the complete electronics. This is the CAN-SAT. There are the telemetry measures. Telemetry measures is any kind of data that your sensor is, uh, you know, the sensor is producing. So this is the telemetry measures, the rocket electronics bay. Okay, so this is the rocket data and the CAN-SAT data. What happens is via two antennas, this is the antennas, they send the command to the telemetry downlink. Downlink is basically when you transmit the data, or when you receive the data, that is called command uplink, or the telemetry downlink. So here in the telemetry downlink, it receives the data through an antenna, and it shows as you can see, the real-time orientation of the rocket is being presented here. So via the sensors, the magnitude and the gyro sensors, you can represent how the altitude, or maybe how the rocket orientation it is at the lifetime when it's going upward. So the ground control station is localized hardware software complex, manages bidirectional communication. Now, what does bidirectional means? Not you can only receive the data from the telemetry end, you can also send any kind of command. For example, after certain altitude, you see the altitude at the ground control station is going up and up and up, since it's receiving the value through the telemetry. And after some time, you realized, okay, now it is 100 feet up. Now I want to just, now I want my rocket to just throw away the CAN-SAT, and you have built some kind of mechanism so it is able to release the CAN-SAT. When you send the command, when you click a simple button like a HTML or CSS button from here, via the JS, the Node.js, it sends the signal to the Python's backend, and the Python sends the signal to the USB that is connected in the your laptop. And your laptop, via the USB, since it has a Zigbee on it, it sends the data to the rocket. So within a fraction of second, all you see is your rocket, just throwing up cans out with a single click of a button. This is so interesting. For for those of you who understood it in the first time, imagine how good of a thing it is. Yeah, I will definitely. Again, this is not a prototype. I will surely send you the link, but this is not a prototype. That's an actual GCS we have built. How latency is minimized in the RF communication between UAV relay and the GSS and the roles of the software. Yeah, my expertise relies within the software optimization for interpreting the data. And in most of the cases, the first thing that you ever go with is just compromising your tech stack in a way that it maintains the bare minimum security and make it working quickly. Oftentimes people don't realize, but they use hard coded or maybe the complex thing for the front end or UI. Why would you want to use TypeScript or Next.js with the Python's backend? That is complex. You have to have a setup for a full project to make it work. That is complex. But if you want a simple project, maybe an HTML, CSS, JS would do. This is so underrated, but people don't really realize it until and unless they go up to the point where they start seeing, okay, it is complex for me to handle how my UI is working. You don't need to do that. Even a simple or the complex interfaces, they can all be built with just the standard of front end three: the Tailwind, the CSS, and the HTML and the JS. JS to basically handle the functionality, JS to basically handle the data receiving from the Python's backend for from the fast API. Okay, so you have built GCS. Can you share experience and difficulties you have gone through? Surely, in the end of the lecture, I will. Um, okay, for those of you who want to connect with me, linkedin.com/. I would- host, can you comment down? It is okay for me to send the LinkedIn.
Sir, we'll forward them your LinkedIn.
Okay, I've commented down my LinkedIn. You all guys can.
Okay, sir,
Computer
no
science.
issue.
Which concepts from this topic are most important, especially in real-time system industry application? See, building a ground control station, some of the concepts are important, and majorly is the part of the backend. When I say backend, there are only two things that matters. First, how you're receiving the data, and that you can handle with the Python SpySerial library. The Python SpySerial library let you interpret the data that you are receiving through the serial communication. That said, when you attach the USB, a simple USB, that is a Zigbee. Okay, so when you're receiving something from the Zigbee, the Python SpySerial library is able to interpret what kind of data and what you are receiving from the Zigbee. Now, you see the problem is at the backend end. It is at the backend. So now you have received the data at the lifetime, and that is going to be really quick. When I say really quick, it's like even less than zero point 0.2 seconds. You will able to receive the data, and then you have multiple calculations. For that you need multiple libraries. Let's say you need to save the data at the lifetime. You need the OS library, .sys library, and let's say you need to have some multiple calculation on it. You need you need the NumPy, and maybe you need to convert the data into, you need to store the data into the JSON outputs, the CSV file, and everything, things like that. Maybe you need to make the API for that data so you can send the API to the front end. Since Python is also used as a backend, not just to receive the data, it is also used to send the data to the front end. So you can have your interface seeing that, okay, what kind of data is being received. Okay, so yeah. So these are the things that matters, and anyone who is starting to build a ground control station, I would highly recommend to start building a simple interface. that does not really require complex libraries to function. You can just, ask for a simple template. Even if you don't know the front end, you can ask a simple template for a chat gpt. You can create an API for that using fast API. In the Python, you have a library for that. And the medium of communication between the front end and the back end is through a protocol that is known as WebSockets. You can utilize WebSockets for that. Via simple combination of these libraries, you can make the simplest ground control station and it would work. It would definitely work. Um, video components for a prototype. I did not buy components. I stole it from my teammates. That's the key. So, if you can, I would suggest you to steal it from your teammates. So, will there be any practical session for this topic? Yeah, definitely. This was supposed to be one of the practical sessions, but surely my friend Anshuman, he's also a lecturer. He's going to take the next session, and he's also built the ground control station with me. So other teams, the teams from different colleges, they would require a team of 5 members to just coordinate a simple ground control station, and we were just both doing in our laptops. We'll just you know Okay, I'm going to forward the Jesus link, but let's just understand things. Okay, just focus on this lecture. You have everything. You have me. How even even after the lecture, but right now, just understand this. These are the core engineering mandates that matter. The capturing high frequency, that is the part of the hardware. The real time telemetry, again part of the hardware. 50% part of the software as well. Then you convert raw data packets. Raw data packets, that mean the hexadecimal or the binary kind of thing, into actionable human readable metrics. That means the front end may it is written that altitude is equal to 0. But as soon as the value received in the byte format, it is interpreted through a ground control station from the interface, and you can see that altitude is 23. The control, okay, the transmission precising. So you can transmit the data, verifiable actuation command, like say parachute deployment. After a time I want my rocket to deploy the parachute, so I need to send some kind of command from the ground control station, right? The preservation, security, continuous data logging for post flight analysis. So this is one of the important things. After the rocket is down to the ground, you might want to know that what happened while it was up. Without a ground control station, it will be just the core part of the engineering that you cannot study on. It happened. Just like you engineered a rocket you see in Diwali, you did everything you could, but that does not, that also have a nose cone and an ignition engine, and you just, flame the rocket and it goes up and comes down. What happened? You don't have any kind of data. So you need to have some kind of data so you know that you spend your money right. Okay, so you can interpret that while it was above there, what happened. So let's understand the tech stack architecture, what we have been waiting for. Okay, so this is the system boundaries dictate that the GCS encompasses layers 2 and 4 heavily, relying on strict protocol compliance from layer 1. Okay, so what is layer 1? This is the payload layer. You have the microcontrollers, you have the sensors, you have everything. Look at just this. Okay, you don't read this. I know you will be having problem. Most of you will having problem understanding. So don't read this, but understand that this is the payload layer. This is the hardware end layer. Okay, so the microcontrollers, the sensors, who actually feel what is going in the environment, they will collect the data. They will recognize the data. They can understand that what's going on. They are the one to generate the data. Then the physical link layer. So what happens is the transmission. Okay, the bands like Yagi and Omni antennas with the RPSMA connector, the radio frequency, these kind of thing. The physical link layer. How good is both of the antennas at the receiving end and the transmission end? How both of the antennas are, established. The connection between them. Okay, how reliable the connection is. The layer 3, that is the hardware layer. Now the Zigbee, the laptop, is it of the OS containing Windows or the Linux? Okay, so both have different option for ports. USB serial adapters. Okay, so this is one of the part of the software engineering, that when you have to make a software that is reliable and portable for any device to use, you also have to think of the parameters like, okay, this works on my laptops. This works on my laptop. I have Windows laptop, but this doesn't work on Linux. So it does not work, and when it works on Linux, it does not work on Windows. So all of you software engineers out there, I want you to know that, okay, this is something that you have to be take care of. When anybody at the GitHub will see your project, how did you do? What have you done? Okay, these things. And let's say you say that it's working on my laptop, and they'll realize that, okay, it's not working on their side, so they'll just ignore it. Then the USB serial adapters, the Zigbee adapter is basically how we set up the communication from transmission to receiving end through Zigbee adapter. That is the simply a USB cable. For those of you, it's being complicated, I know. It's just a USB cable. Okay. Layer 4 is the application layer, where you use different UI, the CSV logger, the mapping, the graph, everything, to understand that what's working and what's not. The application, the main user interface. So any kind of user who has its role in the hardware, who does not understand software, they'll just see the UI. Okay, they'll see, okay, the rocket is going up and up and up. The altitude of the graph is going up and up and up. They won't be able to see the rocket after what, 800 meters. Okay, but you from the ground control station, and you can see that where it is going. um, Core software capabilities are telemetry decoding, data visualization, redundant logging, command transmission. Okay, these are the things that matters. Telemetry decoding is how you are able to validate that what kind of data you are receiving at the front end and the back end is same. Suppose you are receiving A, B, C in the back end, but you are only able to forward A and C in the front end. Where did the B go? There are problems like that. So you come up with things like checksums, and checksums to match. If the data checksum is basically, let's say, you are sending the value 1 plus 2 plus 3 from the sensor end you are just giving three values, 1, 2, 3. So the total checksum is going to be 6. Okay, then you send four values, 1, 2, 3, and 6. The front end, or maybe the ground control station, when it receives the 1, 2, 3, it will also ask for the next number, that is checksums. It will ask for, okay, I need the last value as well. So it will calculate. Let's suppose it did not get the second value, so it only got 1 and 3 value. So it will say that where is the second value, since the checksum is 6. You have sent me 6, but this is just 4. That is 3 plus 1. Okay, so things like that matter. For the more description, you can, for more of the understanding, you can video call me on LinkedIn. Uh, I'm just kidding. You can, ask me after the class as well. So this is the telemetry decoding. Then we have the data visualization. You use real-time dynamic graphs, the chart.js, the live chart.js, the 3D altitude, GPS coordinates. I want to know that, I want to see in the Google Maps, like, when you see the maps in Uber, when you see the Google Maps, okay, that I'm heading to this point and this point and that point. So you want to see something like that on the ground control station as well. So that is really one of the greatest feature I've ever built. Not I've built, I've utilized. The redundant logging writes raw decoded data into non-volatile memory, CS format. Okay, so there are two threads. Threads basically means, let's say there are two processes going concurrently. First, it's your back end is giving the data values to the front end, so that it can be deployed. It can be, look in the real time that how your software is, how the user interface, the graph, and everything like that is functioning. The second thread and the second process that goes on in the back end, that says, okay, while you are sending this data to the front end, also save this data locally. So at 1 second, you received the data. Within that second, you're going to display the data to the front end, and you're going to store the data at the same time in the local storage. So it is easy for you to analyze what happened after the flight. The command transmission is basically you send command like calibrate. Calibrate means set the altitude of the rocket to 0, and maybe deploy the parachute. So you set up a command for that in the backend. And when you say that when you receive a value like X from the front end, you tell the backend when you receive the value like X from the front end, just send the X to the antenna. And when the antenna is programmed in that way, when receiving the X value, initialize the process, just throw off the CAN. Okay. I hope this lecture is not that much complex for you guys. Any kind of queries, anything you want to ask, please, this is the time. I will, yeah, don't worry about the project, worry about understanding. If you have built the project but you don't understand, then it's a waste. And if you understood but were not able to make up the project, then it's good. It's not that bad, but it's fine. Yeah, it is very interesting, right? Being able to see that your rocket, you send something, a little command from the ground control station, and you see that big chunk of the, heavily engineered rocket just performing on your clicks. When we click something, when those who have the experience with the web development, when you say when you click a button, some kind of animation pulls up and you are so happy that okay, finally it worked, it looks so good, it's so great. When I click the button, the images start rolling. This is so exciting. So when you see that real thing going on a real hardware, that is engineering. That is the thing when that's no one is doing, literally no one. But in resume, they will see the project. Yeah, they will see the project, but it also depends. Like I've built several of the ground control station, but I have not put anything in my project since job is not the perspective right now. You have the knowledge, you will find a job. Since most of the engineering students I've seen, they are just worried about getting a job rather than creating a project. Create a project, you'll get offers. You ask for job, you won't get anything. Which components from this topic are most important for especially real-time system industry applications? That's what I told. You know, these are the four more important core engineering mandates that you need to know. So, redundant logging is used for post analysis, like after the mission concludes and the panel with the data. No, after the mission, after the data stops sending, after everything is done, you have a log. You have the CSV file that concludes of any kind of data that you have received throughout the process. And since you have the CSV, since you have the data, now you have the machine learning techniques. Now you have the deep learning techniques. Yeah. Now you have the AI for the analysis. Now you are the data scientist. At one end, you are the software engineer, and after the project is done, now you are the data scientist, doing analyzation on your projects and explain how we can connect the hardware and software parts. Yeah, it wa it would be really great for me if the what do I say this uh, what was that? Yeah, if the whiteboard is working, but yeah, I will. Okay, I think it's time. So how many of you want to continue from the understanding what going on in the theory part, and how many of you really want to see a ground control station right now? Yes, write GIT for the GitHub, and write lecture for this theory lecture. Okay, 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 okay. Yeah, that's what I was talking about. Don't worry, for those of you worrying about the lecture, there is next lecture tomorrow, so you will not miss the. Okay, okay, okay. There's some kind of. Hmm. Okay, so let me just let me share my screen quickly pull out the repo, show you guys. You will have the repo. So even after the lecture, you can understand what's going on throughout the backend. And for this theory lecture, you will have another class tomorrow. So don't worry about that. Okay. I want to learn more about satellite technology. Getting deeper knowledge in this field. Definitely you can. I want to learn. Yeah. Okay. So let me just conclude everything quickly. This was the telemetry packet autonomy anatomy. Sorry. So this is what basically you receive. This is how to structure. This is a way to structure your telemetry packet. When you're designing something in the back end or when you're designing something at the hardware end, the microcontrollers that they are also used as the C++. They use CPP for that, so you can understand, you can create some kind of the telemetry packet and would look exactly like this. I'll send you the PPT, but don't worry about this. This is not something to be worried about. This happens in real systems. When in a personal or an individual project, you don't need that. Real-time software architecture, this is what happens. Save everything in a buffer, background decoding thread, and then the decoder. So basically, then after that, there is a dispatcher and then is a render log. What happens? This is the process flow. Okay, how you receive the hardware, how you receive the data, how you store it, how you decode it, how you present it in the UI, and how you store it. Just four simple steps. Okay. Don't worry yourself with the terminologies in the software and these things. These are things are really simple, but most of the people just say, okay, buffer, serial buffer, background decoding thread. This must be some kind of complicated thing. No, it's not. It's just decoding. It's decoding the transmitted packets. Okay, so design constraints, rocket versus CANSAT. The primary goal in rocket GCS is to flight tracking, the trajectory validation, a recovery mechanism triggering that where the rocket went. But when designing for GCS for a CANSAT, we more need to have a visualization on how the sensor data is looks like. The environmental telemetry interpretation, that is it able to calculate the precise data for the CANSAT, is able to show. So when we're talking about the precision, in the GCS, there comes the rocketry. When we are talking about the not the precision, but the UI part, the CANSAT is the case. Telemetry rate, okay, in the rocket 10 hertz से भी ज़्यादा हो सकती है. 10 hertz means every second you can receive, every 10 seconds you can receive one packets. But in the CANSAT, precision is the key. So you need data packets every second. You need to you need to present the UI every second, like 1 2 3 4 5 6, every second it's going on. But in the rocket, you see, you can even compromise for latency up to 10 seconds. So that's great. The critical metrics, velocity, peak altitude, these kind of things are critical. But barometric pressure, humidity, payload statement mechanics, these are the things that require in the CANSAT. The hardware demands, rocket goes for the long range. CANSAT needs the omnidirectional, the antenna which can, sends the radio waves in any directional. It is short range, so it has localized network. High gain directional antennas to main the high velocity lock. So when the rocket, it's like shh, and it goes up very quick. So you need to have some kind of lock mechanism that, oh, okay, that locks the data. So you do not lose the condition, the communication, the signal. Okay. So yeah, for those of you who are worrying about what kind of problems you face in the software ends, this I've built a table for that. And for the data pipeline from the center to screen, this is what happens. I have explained it. The data is generated, it is packaged, and then it is transmitted to the ground control station. Then we have the acquisition, and then we decode and we display and we store. Okay, this is the system validation, the best practices, how your GCS can, how you can use the hardware in the loop. First, you don't need antenna, any kind of antenna, just integrate your USB, like the microcontroller, into your laptop and see if you are able to receive the data.
After you can interpret the data that what your directly connected Uno is saying, you can surely integrate the Zigbee later. And that is for the testing and simulation. There were a lot of times I was at lot of the times when I was there, at the competition, I was not relying on the Zigbee for testing. I kept a stolen from my friend at myself, and I was testing my software on that. Okay, so one of the guys who were asking the questions, that is how we interpret the data. From the multiple structure, from the multiple satellites, we receive the data. It may be possible that we receive the data from the multiple satellites. Well, for that, we need to make a thread for every group of satellites. One thread would receive the data from satellite 1, 2. Second would receive from 3, 4. Third would receive from this one, fifth. And the fourth thread would combine all of the data into the meaningful packet that we need to compute. As simple as that. Okay. There are threads, there are processes. And the synthesis and system reviews is basically it tells you the architecture, what is it, how does blocking the main UI thread compromising the mission's data integrity. Okay, so the UI is the key factor. The trade-offs when designing for extreme altitudes. Why might a team choose a lower bandwidth LoRa link over a high bandwidth 2.4 Zigbee? So it is about the hardware. So resilience, if the telemetry package fail its CRC checksum validation, what is the exact operational sequence in the GCS should execute? These are the things, the advanced things that you will learn in the, you know, uh, in tomorrow's lecture. Okay. Any kind of doubt anybody would like to ask? Silly, complex, any kind of doubt. In case of communication loss from the antenna, the only thing you can do in your GCS is to show dummy data. That is illegal. Kind of. That feels illegal. But as long as you're receiving the data from the antenna, that means your laptop is receiving the data and you're not able to show it to the front end, you have certain measures for that. That is the checksum. So, Shivam, uh, go for the checksum. Search what it is and how we implement it. What are the materials we need to build a launch and control a CAN set? Are you talking about the data set? The tech stack. I need you to help me for developing a GC that is fail-safe for a competition in 4 months. Okay, so what kind of competition are you going for? Is there any GCS currently developed for underwater data? Yeah, there is. In fact, I've also built one like that. It was for my second year college project. Opening urgency link. Sir, I need you to. Uh, I would not expect anybody to send any kind of link, and I would not tell any member in this chat to open any kind of link apart from what I sent. Sir, in the GC software, how do front-end and back-end system interact? I'm gonna tell you later. Okay, since we are done with the lecture, we have still 13 minutes. Do you think we should go for the git? Do you think we should go for the git? Yeah, and that's the interesting part, seeing the code, how it works. These are the engineers. They don't care about the lecture, and that is great. That thing is great. That is what we require. Yeah. Okay. When you said we have methods to prevent correcting faulty data, we're referring to the, hmm, and when you said you were correcting missing important data, were you referring to the computer network methods like internet checksum? Not the internet checksum, though it is a checksum, but at a local level. So it has a protocol. Okay. It is not a network. Sorry, it is not an internet thing, but it is a network thing. Okay. How can we go into rocket science engineering? Just go it. Go for it. You don't ask why. You just go. Okay. So let's just move to finally the git. Finally, the GitHub, the interesting part. that everybody is been waiting for. Is it lagging? Is it lagging? Is it lagging? I think my browser is lagging. Okay, so this let's say github.com/roothats, and this is my GitHub. Please don't look for the other projects that I built. Is mainly from my for my clients, so I cannot really you know keep that private. But I would not like anybody to fork the repos apart from these two. This is Vajra GCS, and this is the GCS in-space model rocketry for Trishul, the team from PSIT Vyomnauts, and this is the Vajra. Okay, so let me show you both of them one by one. Let's go for the in-space one. See, this is the repo, and before anything, let me hand you this. So you can poke this repo onto your own. I've sent the link. Okay, so just follow up this link. Uh, yeah, let's clone this. See what it is that we need to move. Okay, so first you just clone the repo. You serve the front end and you see the result going on to the local host. Since we don't really need any kind of a third party interface for that, or we don't need to do anything like npm install for the package builds. There is nothing in there. This is just the front end part. You go into the front end, you'll see this, the GUI, the HTML, the script and the style, everything. This is the GUI. And then you see the assets. Assets, they contain, these assets, they contain of the real telemetry data that we got from the CANSAT. Uh, yeah, and this is the flight. Okay, okay, okay. um, अभी मीटिंग में अभी आते हैं. अभी मीटिंग में आते हैं. Okay, so this is, you see, this is the live telemetry data. This is the live data that we have got from our competition on rocketry. See, this is the best thing ever. Receiving something from the hardware end. So I think I need to private this repo. There are a lot of, this is the team, by the way. Okay. Yeah, this is our rocket. That's what we have built. This is another image of our rocket. This is the trophy that we got. The trophy and this is the camera feed of when the Trishul, or when our rocket was at maybe above 2000 feet above the ground level. You can see this is the camera feed, and that looks so great. Imagine capturing something from the ground control station to the rocket end. This was this is our team, and yeah, that's all about it, I guess. Uh, yeah, this is me. I mean, your lecturer, you know, uh, with a laptop trying, and this is the antenna. This was the antenna we were using. So yeah, this is just a glimpse of what we have been through. Although all you need to focus on right now is the code that I was talking about. This is the GUI. You just copy the GUI, the script, and the style, and you're done with it. You don't need anything else. Just copy these things and you look up for the changes. This will tell you what the script file is all about, what it does, and how you can, operate it. These are the gyro elements. Now, okay, then there is anything. Okay, now that I remember, this software does not comprises of any kind of backend. It runs purely on the script. Okay, it understands the data. It receives since JS, the Node.js can be served as backend as well, and even for the functionality. So all you need is one single file for everything. Okay, this is approximately 3,704 lines of code. Of course, we have used AI. It is not something that we have built from scratch. What propulsion system? Maybe that my friend from my teammate would be able to. You just for the one for the this doubt of propulsion system, you can message me on LinkedIn. LinkedIn. I will surely connect you with that guy. Where was the launch site? Gorakhpur. That was the propulsion system. Beautiful. Okay, so let's now who want to see the interface, the GUI? You must be thinking that with just HTML and CSS, it would look like, it's absolutely bad. That's not the case. Okay, so let's just go with seeing the front end. That's interesting part. Let me search for front end. Go to for any of you trying to build a ground control station, you can go to that repo. Search for I hope you guys can see. And this is it. This is the GUI. And my friends, this is the ground control station that I built. Okay, so this was the simplest ground control station. And for those who want to know how it worked, I can show you that. Just a minute. With the simulation that I built, I need a JSON file, and all I need to go is look for let's upload a CSV. Copy location. Instead of JSON, I have an option. I will upload the CSV. Home desktop. Let's choose up with any kind of CSV. Okay. And then we play. So you see the data live being updated. You can see that 3D the orientation of the gyroscope is changing. This is the real-time graphs we have included the altitude, temperature, pressure, CAN-SAT, rocket gyro, voltage, time, and this is the live map we included of the GNSS location tracking. It automatically calculates the distance between the CAN-SAT rocket, the CAN-SAT to the ground, and the rocket to the ground. You can also set the manual coordinates of the ground control station here by writing or typing them, or yeah. So you can also see all the timestamp rocket GNSS data here, and yeah. See, this is the data live being updated. This is the raw serial log where you receive all the data. There is the rocket orientation changes, and you see the other sensors values. These are the values that I can send, like ready, stop, these values. These are the command panel. I can send any command that I want. Okay. So yeah. So this was all about today's video. I hope you understood something. You have taken out some kind of knowledge from this lecture. I would surely hope and wish best for your future, for making a good, maybe highly complex and ground control station for your project requirements. Anything other than that, you can message me on LinkedIn. And yeah, so I would now request the host to end the meeting. Summarize today's lecture in short. GCS software interface for a hardware. Use telemetry packets. You send that in the front-end UI, and the hardware guys see that. That is all about today's lecture. Okay. Yeah, surely I will accept everybody's request on LinkedIn. Any kind of doubt you have, you can ask me.
Sir, I don't think so.
Okay,
There is any doubt.
26 people have sent me the request. That's
If any participant
Yeah.
has any doubt, kindly raise your hand.
okay.
So, shall I conclude the session now? So, shall I conclude the session now? So, am I audible to you?
You guys all look like smart people. I don't know why.
Okay, sir. Thank you for such an insightful session. Thank you, all the participants. Now, you all can leave the meeting.
Okay. We have okay. Any kind of doubt you want to ask, you can ask me.